This is chapter 15, video assignment number 1, and the problem that we are asked to solve is you have a solution that is 0.00100 molar is chloride and 0.0100 molar is an oxalate. Your job is to remove the chloride and keep the oxalate. You decided to use the selective participation with silver. The solubility product constant for silver chloride is 1.87 times 10 to the negative 10, and the solubility product constant for silver oxalate is 5.40 times 10 to the negative 12. You will add silver 1 nitrate dropwise to increase the silver concentration until one starts to precipitate. Then continue adding it until you get just up to the concentration where the other starts to participate. So for the first part of this, we're going to be calculating the concentration of silver ions where silver 1 chloride starts to participate. And then we're going to calculate the concentration of silver 1 ions where silver 1 oxalate precipitates. And then we're going to answer once we raise the concentration of silver up to the concentration where silver oxalate starts precipitating, what is the remaining concentration of chloride? And then after we figure out the remaining chloride, we're going to find the percent of chloride that is removed. So here is my work for this assignment. Here. And first up here, I just put what we are given, right? So this is the KSP of, why can't I think of the name? Silver chloride. And this is the initial chloride concentration that we have. And so that's going to help us answer the first question, which is calculate the concentration of silver ions where silver 1 chloride starts to precipitate. So as you can see here, the KSP of silver 1 chloride is equal to a silver ion and a chloride ion. And what we are looking for right now is the silver concentration. We're looking at when it precipitates. So in order to do that, we need to solve for silver. So I just rearranged the problem down here to solve for silver to make it easier. So that silver is equal to the KSP over the chloride concentration. And up here, we are given the initial chloride concentration here. So we just plug that in right here, 0.00100 molar, over the KSP that we are given, which is 1.87 times 10 to the negative 10. Just put that up here. And that gives us the total amount of chloride that started to participate, or the concentration of silver ions where silver 1 chloride starts to participate. That's 1.87 times 10. I can't even read that. 10 to the negative 7. And then the next question that we are asked is to calculate the concentration of silver 1 ions where silver 1 oxalate precipitates. Now this is a separate thing where we move from chloride to oxalate. Oxalate is this right here, C2O42-. And as you can see here, I wrote this KSP out as I wrote here for B. But as you can see, this silver is squared, and this is important to remember. If you forget this, you'll get the answer wrong. The reason that this is squared is because this whole thing is to the negative 2, and so there has to be 2 ions of silver in the reaction. So make sure this is squared. And again, we are looking for, scratch that. We are also given the initial concentration of C2O42-, and that's 0.0100 molar. So just like we did up here, it's just the same equation using different chemical or ions in a reaction. Anyways, so just like we did there, I'm going to rearrange the problem to solve for the silver ions that we're looking for. So as you can see, I solved for here, KSP is in the numerator, and then the concentration of, the concentration of oxalate is over here. In the denominator. So then you just plug that in the KSP that we were given is 5.40 times 10 to the negative 12. And the concentration that we were given is 0.0100 molar. And then solve for that. Remember that this is squared, so you do have to take the square root of your answer. And the answer that you get is 2.32 times 10 to the negative 5 molar. So basically what we did here is we found out when this starts, or when the silver starts to participate and oxalate. So the number that we found is when this number, or when silver starts to participate here, that means chloride is going to stop precipitating here. So what we're going to look for is the remaining concentration of chloride that we have after it stops reacting with the silver here, and the silver starts reacting with oxalate. So we're just looking, we found this number so it can lead us in to the next question, which is, once we have this concentration of silver, where the silver oxalate starts precipitating, what is the remaining concentration of chloride? So just like in our first reaction that we did, I think I wrote it down here as well, wherever that is. Oh, here. The KSP of, I can't read that, oh my gosh. The KSP of AgCl is equal to Ag and Cl, and now instead of finding the initial concentration, we're finding the remaining concentration. So we're just going to use this number that we got and plug that in to where we have silver. And I did solve for Cl right here, so it's easier to plug it in. We use this, put it in where the silver is, which is 2.32 times 10 to the negative 5. And then we use the KSP that we have from question 1, which is 1.87 times 10 to the negative 10. And so the remaining concentration of chloride that we have is this number right here, which is 8.06 times 10 to the negative 6 molar. And then once we find the remaining concentration of chloride, we were asked to find the percentage. And the percentage of this is really easy. It's just the initial concentration that we have minus the final concentration that we have over the initial concentration, and then just multiply that by 100. So the initial, which is what we were given, 0.00100, is that minus the number that we just got, which is 8.06 times 10 to the negative 6, all over the initial 0.00100 molar, and that is going to yield a percent of 99.2%. So that means that, yeah, the percent of chloride that is removed is 99.2%. So there's very, very little chloride left over.